Okay, so as in the last video, we have started discussing about the mixture of volatile with more volatile, right? We initially discussed that we're gonna mix volatile substance with volatile, and we're gonna apply the Raoult's law in it, and then we will be mixing volatile with non-volatile, and then again we will gonna apply the Raoult's law in it, right? We firstly discussed the volatile and non-volatile substances. We differentiate them both. So what were volatile substances? Volatile substances which can create vapor pressure, right? Which have an ability to create the vapor pressure, and we have seen its examples as well. Ethanol and glycerol are the best example of the volatile substances, right? If I do take ethanol or glycerol, they have ability to create the vapor pressure, right? If I do take these both in the closed container, at the point of the equilibrium between evaporation and condensation, they will gonna generate a pressure on the wall of the container, and that pressure is what we call the vapor pressure, right? So these both substances, ethanol, glycerol, we have a lot of more substances which have ability to create the vapor pressure, but here we are talking about best examples, right? So ethanol and glycerol, they both have an ability. When we take them both in the closed container, they have ability to create the vapor pressure at the equilibrium of uh, evaporation and condensation. Okay, and on the other hand, we discuss about non-volatile substances, which means which does not have an ability to create the vapor pressure in the closed container. For example, urea and NaCl, right? Then we mixed volatile with volatile. For example, we took a substance that is volatile, of course, right? Here the substance A which we have taken is actually volatile substance. Let me mention this here. Volatile substance, right? We have mixed this with B container, which is again volatile, since we are initially mixing volatile with volatile. So this is volatile substance as well, which means both have the ability to create the vapor pressure, right, in the closed container, of course. So initially we took A in the container, right? So we already discussed that they will gonna have their pure vapor pressure. This A will gonna have its pure vapor pressure. Since not anything is mixed with it yet, we are going to mix it with B container, but initially it is not mixed with anything. Only A particles, A substance is there in this container, in this beaker. That's why it has only vapor pressure of A, and this we have named as pure vapor pressure, right? P naught of A represents pure vapor pressure of A. We are going to mix it with container B. Again we are going to mix it with container B. We have not mixed it with container B yet, but we are going to mix it with container B. So this B molecules have their own vapor pressure, and this is what we have called pure vapor pressure of B. P naught of B is pure vapor pressure of B. P naught of A is pure vapor pressure of A. Here the pure vapor pressure of A and pure vapor pressure of B would both be not considered, right? Since now we are going to mix it. If they both would have been mixed with each other, they will gonna have now partial vapor pressure, right? Because initially it had its own vapor pressure, P naught of A, pure vapor pressure of A. Since it was not mixed with anything, then B1 was having its own vapor pressure as well, right? P naught of B, P naught of B, which means pure vapor pressure of B. But now as they both are mixed together in a container, now they both have some properties of each vapor pressure exist in them, right? Now this A molecule will not have its pure vapor pressure, but it will gonna have PA, which is only a vapor pressure of A, right? Only a vapor pressure of A. So not pure vapor pressure of A, only vapor pressure of A. This B will not have pure vapor pressure of B, but this will have only vapor pressure of P, which means they will gonna have vapor pressure. Since both are volatile substances, A is volatile substance as well, B is volatile substance too, but they will not have pure vapor pressure since they both are now mixed together with each other in a container, right? So now they'll have a vapor pressure. I am not saying that they'll not have a vapor pressure. They'll, of course, definitely will have vapor pressure, but not pure vapor pressure, since only vapor pressure, right? Now we are going to apply the Raoult's law in it. You need to remember this. What we represent pure vapor pressure of A with? P naught of A, which represents pure vapor pressure of A, right? And then we have P naught of B, which represents pure vapor pressure of B, right? Now we have PA only, right? PA. PA only represents vapor pressure of A. Not pure, but only vapor pressure of A. Pressure of A, right? Then we have PB, which represents vapor pressure of B. Vapor pressure of B, right? So P naught of A represents pure vapor pressure of A, P naught of B represents pure vapor pressure of B, PA represents vapor pressure of A, PB represents vapor pressure of B. Now what does Raoult's law say? Let's apply Raoult's law in it. In a solution, now see, this is a solution we have. This is a solution, right? In a solution, the vapor pressure, you need to understand it, right? The vapor pressure of each